So today we're going to be looking at curve of best fit. So far we've talked about how in standard form for a quadratic it's going to be ax squared plus bx plus c, where the x squared is in the front, the x is in the middle, and our constant is in the back. We've talked about vertex form, where we have a x minus h squared plus k. We know that h and k are the vertex, and a is the size of the compression or the stretch. So before we were talking about line of best fit, and in Desmos we would type in y1 tilde mx1 plus b. For curve of best fit, we actually use the standard form. So we go y1 tilde ax1 squared plus bx1 plus c. So notice we took this standard form equation and we're transferring it to the curve of best fit formula. So we want to figure out which model best fits this data set. We want to know whether or not it would be more appropriate to talk about a line or whether it would be more appropriate to use a curve. So what we're going to do first is we're going to type in this data. We do that by going to the plus sign, creating a table, and I'm going to start entering the values in. To see what this data looks like, I click on this magnifying glass here in the corner, and we should get a zoom fit. All right, so judging from this data point, I think that a line is probably the most appropriate model for this data set. So if it's a line, that means that to find the line of best fit, I do y1 tilde mx1 plus b. And I can see that m is negative 2.8, is b is 88.6. So the line of best fit is y equals negative 2.8x plus 88.6. Predict the final grade for 11 absences. So I go back to my graph. I find approximately 11 absences. I go to my line, and it looks like at 11 absences, you would predict the final grade to be 57.8%. So what we did was we entered the data into Desmos. We went and looked at what kind of shape the data made. We determined it looked like a line, so we used our line of best fit formula to figure out the equation for this line, and that way we could make a prediction. Let's try one more. On this side, we have a new data set, so I'm going to make a new table. And I'm going to zoom out to see what kind of shape it is. So you can kind of tell that this is going to be some sort of curve. If I do y1 tilde mx1 plus b, you can see that this line does not really match this particular set of data. However, when I type in the standard form for quadratics, sorry, I made a typo. You can see that this is a better fit for this data set. So when I look at this data, I believe that this is a curve. And then the formula is down here at the bottom. Instead of m and b, it gives you the a, the b, and the c. And we're going to round to 2 decimal places. So the a value is 0.14 x squared. The b value is negative 5.83 x. And the c is 61.5. So this was a, this was b, and this one was c. If we want to make a prediction for what the output is going to be when the input is 18, I come over here to my graph, I approximate where 18 is, and it looks like, I just had it, 18 is going to give you an output of 2.331. So this data set was more appropriately modeled by a curve. We found the equation for the curve of best fit, and we were able to use that curve to make a prediction. Our last model looks like this. you can kind of tell right away that this is going to be some sort of curve, right? So I think it's fair that we can just circle curve right away. So the first thing I'm going to do before I put it into Desmos is make a table. So 0, 80, approximately 1, 120, 2, 140, maybe 3, 130, 4, it's close, so maybe 75, and then 5, 0. So this is the data set I'm going to put into Desmos. Yep, so that's a good match. So we've determined that this is a curve already, so I'm going to be typing in the standard form for a quadratic. It's a pretty good fit. And then I'm going to record my A, my B, and my C. And I'm going to do 2 decimal places, so negative 15.63 x squared, that was my A. B is 62.55. C is 77.68. 77. That's my C. So this right here is the equation for the curve of best fit. And at 1.5 seconds, I am predicting that it is going to be, I just had it, approximately 136 feet above the ground. 136,353. All right, so when you're done taking notes, it's time to do some practice. So go show Ms. Hammond your notes and grab the practice for today.